In addition, shared memory accesses can be synchronized using operating system-provided mechanisms for inter-process interactions. This is particularly important because the process shared option for the mutex condition variables with pthreads isn't necessarily always supported on every single platform. Instead, we rely on other forms of IPC for synchronization, such as message queues or semaphores. With message queues, for instance, we can implement mutual exclusion via send-receive operations. Here is an example protocol how this can be achieved. Two processes are communicating via shared memory, and they're using message queues to synchronize. The first process writes to the data that's in shared memory, and then it sends a ready message on the message queue. The second process receives that ready message, knows that it's okay to read the data from the shared memory, and then it sends another type of response, an OK message, back to P1. Another option is to use semaphores. Semaphores are an operating system-supported synchronization construct, and a binary semaphore can have two values, 0 or 1, and it can be achieved the similar type of behavior like what is achieved with a mutex. Depending on the value of the semaphore, a process is either allowed to proceed or it will be stopped at the semaphore and it will have to wait for something to change. For instance, a binary semaphore with values 0 and 1, we can use it in a following way. If its value is 0, the process will be blocked. And if its value is 1, the semantics of the semaphore construct is such that a process will automatically decrement that value, so it will turn it to 0, and it will proceed. So this decrement operation is equivalent to obtaining a lock. In the instructor's notes, I'm providing a code example that uses shared memory and message queues and semaphores for synchronization. And the example uses the System-V or System5 API as a reference. The System5 APIs for these two IPC mechanisms is really somewhat similar to those that we saw for shared memory in terms of how you create and close, etc., message queues or semaphores. For both of these constructs, there are also POSIX equivalent APIs.